Alright, welcome back guys. And today we'll be solving Chakravyuha. The name is pretty cool, no? This problem is lengthy. It is pretty lengthy and it is a bit intimidating because it has just so much of these numerical values in these figures. But worry not, this question is not that tough. I mean, it's not that easy like we have a one-liner solution for it or something like that. But it is not a very hard level question. Okay, it is a question based on matrix, a 2D list, okay, 2D arrays. So I can assure you, once we are done with this question, you will be just so much comfortable in doing questions with 2D array because you'll have those on your fingertips. Okay, so let's move on to the problem description. During the battle of Mahabharata, when Arjun was far away in the battlefield, Guru Drona made a Chakravyuha formation of Kaurav army to capture Yudhishthir. Okay, let's learn some history. Abhimanyu, young son of Arjun, was the only one amongst the remaining Pandava army who knew how to crack the Chakravyuha. Okay, he took it upon himself to take the battle to the enemies. Abhimanyu knew how to get power points when cracking the Chakravyuh, so great was his prowess that the rest of the Pandava army could not keep pace with his. Okay, so this is the first key point that we need to know, that uh, we are supposed to collect some power points. Okay, this is one part of the question. Now, worried at the rest of the army feeling behind, Yudhishthir Maharaj needs your help to track Abhimanyu advances. Write a program that tracks how many power points Abhimanyu has collected and also uncover his trade. So we have to also, show the path that Abhimanyu has followed while cracking that Chakravyuh. So this is the how a Chakravyuh looks. It is a wheel-like formation. Okay, this is its shape. It's sort of a maze, a circular maze. Okay, and just rotate it and you will get hypnotized. Okay, so right. A Chakravyuh has a well-defined coordinate system. Each point on the coordinate system is manned by a certain unit of army. The commander-in-chief is always located at the center of army at better coordinates its forces. Okay, to better coordinate its forces. The only way to crack the Chakravyuh is to defeat this unit in the sequential order. What does he mean by sequential order? This order, this line, the path that it follows. First, he has to move right, then he has to move to the bottom, then he has to move to the left, then he has to move again to the top. Okay, and this is what he meant by the sequential order. And so basically, they have also provided you the written formation like 1 2 3 4 5, and then to the downside 6 7 8 9, and then to the left 10 11 12 13, and then to the top 14 15 16. So this is how the army units are placed, and this is how Abhimanyu is supposed to kill all of these enemies. Okay, so the entry point of the Chakravyuh is always at 0 comma 0, which means Abhimanyu will always start from this 1, which means this is entry point. Okay, so and first unit Abhimanyu has to march towards Abhimanyu is supposed to defeat this 25th enemy. Okay, so and he is located at 2 comma 2, but he cannot go directly like 1 17 25. He has to follow the pattern. He has to follow go to the sequentially, like he has to first move from 1 to 3 4 then 5. By the way, the number in which they have written these numbers, you have to just follow that path. Okay, now after destroying the first unit, Abhimanyu gets a power point. So it is a given that after destroying the first unit, Abhimanyu will get power point. So uh, he will definitely get a power point after destroying one. Great. Abhimanyu, thereafter he gets one. After that, he gets one after destroying army units, which are multiples of 11. So after that, if he destroys 11, then he gets one power point. After that, if he destroys 22, then he gets one power point. And if there was 33, then he would have gotten another power point, but he can't. Okay. So it's not like we have to just calculate the total number of power point that Abhimanyu has supposed to gather. We also have to show that which path Abhimanyu has followed. Okay, so that is what makes this question a little bit tricky. Otherwise, if we just had to count how many, how many power points Abhimanyu gathers, that could be just done with a formula. And it would have been a one-liner solution, but unfortunately, that's not the case. Okay, so you should also be in a position to tell Yudhishthir Maharaj the location at which Abhimanyu collected his power points. Okay, so we have to also tell that at which exact coordinates Abhimanyu got his power point. Like Abhimanyu will get his power point at 1, right? So we have to print 0 comma 0. Abhimanyu will get his another power point at 11, right? Because he after that he will get it multiples of 11. So Abhimanyu will get another power point at 11. So we have to show the coordinate of 11. So that will be what 4 comma 2, right? Because their indexing start from 0, and we should be glad their indexing start from 0 because are also by default. So that's great. Now input format, the first line of input will be length as well as breadth of the army units. Great. They'll just give you the side and you have to create the square on your own. Okay. Output format, print this n comma n matrix. You have to print this complete thing in this exact same pattern. Okay, now after that you have to print total power points collected. We can do that easily. Print coordinates of the PowerPoint collected in sequential fashion. Okay, sir. And so this is our sample input and output. these are very important, half of the question you can understand by this also. So if the input is 2, then you have to print 1 2 3 3 4. Okay, and the total power point that he connects is 1. That is the starting, that is at 1. Okay, so 0 comma 0. And after that, when the input is 5, we have created this 5 cross 5 matrix, and this is its what this is its in the way he follows, in the way he sequentially moves, like 1 2 3 4 5 6 7 8 9, and then 10 11 12 in this way. And he collects total power point 3, so the 3 power points that he collect are at 1, that is 0 comma 0, right? He collects first at 0 comma 0, and then he collects 11 and 11 at 4 comma 2, so that is our another point. And after that he collects 22 at 3 comma 2, so that is our third point. Okay, so now what should we note here is that since he's moving sequentially, first he moves the first power point that he encounters is at 1, right? So we are supposed to print 0 comma 0 before. After that we are supposed to print 4 comma 2, because after that he encounters his power point at 11, and the next power point he gets is at 22, right? So first we'll print 0 comma 0, then we'll print 4 comma 2, then we'll print 3 comma 2. This sequence is really important. Okay, keep that in mind. So this question, 95% of this question is based on a small concept. I think you might have even heard of it, that how to print a matrix in a spiral form. So we just have to manipulate that little bit of concept, and we'll get our answer. Okay, but by the way, that is really important, because if you are a beginner, if you are a novice and you don't know much about this loops and this matrix printing, then it can be a little bit tedious. But don't worry, because will actually show you exactly and how easily it can be done. So just stay tight. And that is the 95% of part, because once you have just printed, once you have this array, how hard is it to calculate or to get the coordinates of where 11 is, where 22 is it that hard? No, it's not, right? So don't worry, I'll just show you how to print that spiral this how to actually convert this matrix into this spiral form, because it is a spiral, right? 1 2 3 4 5, then this, and then this. Like, isn't this a spiral? Yes, it is a spiral. So I'll just show you. Just give me a second, and I'll get a little bit more graphical. Okay, so I just copied that Chakravyuha figure of size 5, right? This is the same figure. Now, how are we supposed to move? Now, Abhimanyu will start from this point, right? He'll always start from this point, and after that he'll move to this place, to 5, and after that he'll move to this 9, and after that he'll move to this 13, and after that he'll move to the 16, after that he'll move again to 19, then 21, and then 23, and then 24, and then 25, right? So this is the way Abhimanyu moves, right? And how are we supposed to print this? Using some loops. Because what is the use of loops? Loops are used for repetitions. If you have if you are doing some same operation again and again, if you are using a same operation multiple times, and you are just changing some values, then you use what then you use a loop, right? If you are printing a table of 2, then you use a loop, because you have to uh, because the reason we are using loop is because instead of writing that same piece of code again multiple times, we just tell the compiler that execute this line this much times. But for that, there should be a pattern. Right now, is there a pattern? Because first I'm printing this line, then I'm printing this line, then I'm printing this line, then I'm printing this line. There is no pattern, right? If you try to integrate it like this, that's first you will print this row, then you'll print this column, and if you just try to do this, if you just try to minimize your number of loops you use, then you will get into trouble. You get into a very complicated situation. So I always say, the purpose of loop is to repeat something, right? So what I'm going to do is I'm going to find a pattern, and after that, once I find a pattern that is repeating, that is where I'll be using my loops. Okay, so what let's see. First, we print something like this. We're printing this, like from 1 to 5 we come, and after that from 5 to 9 we come, and then 9 to 13, and then 16, right? This is the same figure that I've drawn, right? Okay, then once we are done with this, what we do, we move from 17 to 19, 19 to 21, 21 to 23, and 23 to 24, right? So how does this seem like? After that, we print this again, even though our this pattern is getting a little bit shorter. That is another thing, we'll come back to it later. Okay, actually right now just forget this, we are solving a question, and we are solving check review. We are just right now we are trying to print this matrix in a spiral form. Okay, so how do we do that? Now see, this pattern, what I'm talking about is this pattern, it keep following. Why? because first you do this pattern. Okay, first you move from 1 to 5, then my 5 to 9, and then 9 to 13, and then 13 to 16. Okay, so this is one pattern, and after that what you repeat this pattern again in this format. Okay, and after that if this matrix was any bigger, you'll repeat this pattern again, and after that you'll repeat this pattern again, and after that you'll repeat this pattern again. So this is where you should be using your loop. You should print this, sorry, you should basically you should print this thing, and after that you should use your loop on this thing. Even though you have to, just adjust its size again and again, but worry not, we can do that, right? But now we know where we are supposed to use our loop. Okay, now this way our code will be a lot less confusing for us. Why? Because what I'm going to do is, what my approach is going to be is, I know that I can print this. If I ask you to use an array, can you print this for me? Yes, you can. You are smart enough, right? If I ask you to use another array, uh, once we have iterated to this array, if I ask you to use another array, then can you print me this value? Yes, you can. If I ask you to use another array, and by the way, none of these arrays are nested. Okay, these arrays are one after another. Okay, and if I ask you to use another array, can you print me these? Yes, you can. If I ask you to use another array, can you print me these? Okay, so if by using four arrays you can print me all of these values, right? By using four arrays you can print me this pattern. Yes, and after that what I'm going to do is, I'll use a loop on this pattern. So after that what I'll get is, uh, I have printed this, and after that I'll adjust my size, I'll adjust my boundaries, and I'll print this, and I'll print this. So that is what I'm going to do. Now how will I do that? For that I'll need a few of sorry, for that I'll need a few, basically boundary conditions, right? That's what I call it. So what will my boundary conditions? My boundary condition will be like this. I'll have a row start, okay, and a column start, and I'll have a row end and a column end. Since I have to adjust my sizes, that is why I'm using these four variables. Okay, that is why I'm using these four variables. Okay, now so initially what will be the value? My row is starting from what? 0 comma 0, right? My row is starting from, sorry, my row is starting from 0. What about my column? My column is starting from 0. What where does my row end? My row ends at 4. My column ends at 4, right? I hope you're getting what I'm trying to say. Basically, just give me a second, right? So what will be the index? What will be the index of this point? It will be 0 comma 0, right? That will be index of this point. So my row starts from 0 and my row is in 0. And what will be the point of this, the farthest point? It will be sorry, it will be 4 comma 4, right? So my row ends at 4 and my column also ends at 4, right? Because this is a square. Okay, so what I will do is, now try to focus, because this is the best part. Okay, so what I'll do is, I'll just basically I'll just move throughout this row. Okay, keeping my row basically my row start pointer indicator at the constant, and I'll what will I do is, I'll print this whole. I can do that, right? Once I'm done with this, what I'll do is, I'll change this value of 0 to 1. Now my row will start from 0. For me, now this does not exist. Okay, I have already stored this value somewhere. So for me now this value does not even exist. Okay, so now what? Basically, if you want, you can just remove this. Okay, for me now it does not even exist. Okay, now what? Now I'll move from here to here. Okay, when I move from here to here, what do you think I do? Try to think a little bit about it, because uh, you know basically sorry, basically when I'm moving that way, what I'm trying to just give me a second. Okay, what I'm trying to do is, I have printed this value. Okay, so I've already printed this column and part completely. So I'll just reduce my column into 3, right? I'll just, sorry, I'll just remove the size of my column and after that I'll just delete this part also. Okay, now I have only this matrix text left. Okay, now I'll print this backward part. Once I'm done with this, what will I do? Try to think a little bit. I'll remove this, I'll decrease my row and I'll make it 3. Okay, and by the way, I'm storing these values somewhere. Okay, so now I don't even need to do this. Okay, done. Great. What about this? After this, now I'll print this. Okay, once okay, now if I printed this, then I'll just increase the size of my column, so it will become 1. You see how slowly and slowly my this matrix is compressing, and how I'm compressing it? I'm basically printing all of these parts. I'm printing all of these parts, and I am just removing all of these parts. So this is how my matrix is compressing, right? Basically, just give me a second. Okay, so first I printed this, and after that I increase the size of my row. So now I can't access to this part again, right? Because I'm not going to that coordinates again. So for me, they don't even exist. I don't care about them. Okay, so that is why they are just as good as gone, and that is and this is how my one iteration completes. At the end of my one iteration, I've already just basically traversed the whole of the outer side. I've traversed the whole of the outer part of this Chakravyuha, right? And after that, my my what my basically sorry, I have already printed this part, right? I have already printed this part, but we are forgetting something. My this part, it is in a loop. Okay, it is in a loop. So after that, I'll start again. Great, I'll start again. My loop starts again, right? By the way, what is my condition for my loop? It is simple. I'll just do this till the time row start is less than or equal to row end. Just do this. Okay, that will be my condition. After that, I'll print this. Okay, if I print this, my row start will become 2, and I just remove it again. Okay, and what will I do after that? I'll just print this part. I'll print this part. My column will become 2. Okay, and I'll just remove this part also. I hope you are getting what I'm trying to do. Okay, after that, I'll print this part. When I'm done printing this part, I'll just decrease the size of my 2. Okay, and after that, what even this value does not exist for me. Okay, uh, what am I doing? Okay, and after this, really simple, I just traverse this, and I completely, and after this, I basically traverse my complete graph, and this is how, just give me a second. Okay, and this is how I have basically, what I've traversed my whole chakra review. Now let's move to the coding part, but keep this in mind that how I have done this approach. Okay, now, by the way, I don't think that I even need to tell you this, but what, uh, once, while we are traversing this part, I can check, right, what is the basically at which value I am. Am I at 11? I'll use a num, and I'll keep on at every operation I'll just keep on incrementing it one by one. Okay, and when I've incremented, I'll just check its value. I'll just check if its value is equal to what, if its value is equal to a multiple of 11 or not. And if it's 11, then I'll store its coordinates. If it's 12, 22, I'll store its coordinates again. Simple, right? It's pretty simple. So, and every time you just encounter that, you just store their values and you their coordinates, and you increase the power point by 1. And what, and right, the main question was what, how you approach this question, how you use, how do you print this pattern, how do you print this pattern again and again. That is the main part. This PowerPoint thing, it was just, it was nothing. It was just like finding prime numbers, not actually even prime numbers, very easy, more than that. Okay, so now let's move on to the coding part. I hope you have gotten my approach, what I'm trying to do, right? So just give me a second. I'll just move on to the coding part. Okay, okay, now let's start the coding part. Okay, so firstly, I'll have my input. My input will give me the total number of sites, basically the radius check review. Okay, and after that, I'll create a 2D a 2D list matrix. Okay, I'm creating a 2D list. I'll initialize it with 0. It doesn't matter because I'll soon change these values. Okay, I'll use a counter, a num, and I'll increase it because the pattern was 1 2 3 4 like that. Okay, so for j in range of n. Okay, done with that. Now, since we are supposed to use a lot of loops here, we are supposed to print a sort of series, like, right? So whenever I encounter this question, what do I do is, if I'm doing it manually, then I use a pen and paper and I write down all the coordinates, and then I learn how my loops will be iterating, how my basically counter variables will be moving. And this helps me a lot because this way I am very easily able to find out the patterns. So that is how I'm going to approach this question, and it's up to you if you follow that approach or not. Okay, so this is basically all the indexes for a 5 cross 5 matrix. I've written it down to ease me. Okay, so I'll actually request you to do this because this will make your codings for this question very easier. Okay, and I'll show you exactly how. I'll show you right now. Uh, we are going to use what? We are going to use 4 four variables, right? Four variables for the boundary condition, for the iteration purposes, and for everything, for the for the congesting of this matrix. Okay, so I have this row start, row end, and we have a column start and my column end. Okay, so my row start, my row will always start from where? It will start from zero, right? The Abhimanyu always move from zero. My column will always start from zero. What about my row end? Since this is the 5 cross 5 matrix, my row ends at 4 comma 4. So my row end will be at n minus 1. My column end will also be at n minus 1. See how easy it has become to calculate these values. This is just a small example. I'll just show you even better example. So I'll create my first loop, the loop which is supposed to repeat that pattern again and again. What was my boundary condition for that? Till the time row start is less than equal to row end. And remember, and, because if you don't use and, use or, then you won't be able to print that 25 thing. Okay. And column start is less than equal to column end. Okay, now starts the real part. Okay, so first what I'm supposed to do is, first I'm supposed to do this part, print this part. Okay, and what do you notice? That this row, this row index, it's constant. What is changing? It's my column index. So I'll do that for I in range of, from column start to column end plus 1. Okay, what my g row, my g row sorry, my 0 start comma I, right? What I'm doing basically is, I know that the zero number is constant throughout this iteration, right? It will be constant. What is changing is this number 0 1 2 3 4. So I'm just iterating from this 0 to this 4. Okay, and I'm creating a g initially, that I'm creating a g initially, that 0 was, my g is like this. Okay, initially my sorry initially my matrix is like this. I have not done anything to it, right? So what I'm doing is, I come to this value g 0 comma 0. Okay, uh, and I replace its value with what, with its value with 1. Okay, and after that I increase it 1 1 after that I'll just increase its value. I'll make that 1 2, and after that I come back to this place, right? So my row start will always be constant, right? Because all these values, they have 0 in common. What is changing is the column value. So I iterate from 0 to 4. Okay, so this column coordinate, it is the one that is changing, right? So I just do this g row start comma I, and I'll just equate it to num. By the way, I forgot to initialize this num. This num will be equal to 1. Okay, and after that, what I'll just iterate the, sorry, I'll just increase the value of this one. Okay, I hope you're getting what I'm trying to do is, with this loop I have successfully iterated through this part. Okay, I've successfully iterated through my I've successfully moved right. Now I'll move, just give me a second, I'll actually write the comment. I have moved right. Okay, this is for right. Now what? Now I need to move to left, sorry, move to bottom. But before that, what do I need to do is, I need to increase the size of my row start, because since I've already printed this part, right? Since I've already printed this part, since all the values of my this, they have become like this, then for me, it doesn't even for me now, they don't even exist, right? I have already completed the work for this part. So I'm just what I'm doing, I'm my row start, it was initially pointing to this part, right? It was initially pointing to this part, my row start, but now it will point to this part. Now this is where my row start will be. Okay, now this is where my row start will be. This is how I am going to compress my what my matrix. Okay, so my row start plus 1. Now after that I have to print this part, this 0 4 sorry 1 4 2 4 3 4 4 4, and I notice that column, this column end part, it is the same. What is changing? My row number. Okay, pretty simple, right? So now I have to move to downside. So I'll create another what I'll create another another another, sorry, uh just give me a second. I don't know why it's hanging so much. Okay, so I'll just create another loop, and I'll iterate from row start till what? Till my row end. Okay, sorry, end plus 1. By the way, if you've noticed that initially my row start was pointing to 0, right? But now my row start is pointing to 1. So now I can just start from this point. I am starting from this point. I don't even care about this point, right? And that is why we increased row start. That is how we are compressing our matrix. Okay. So sorry, this row end plus one. Okay, now I'll just use another what? I'll just use another sorry, gi and column end, right? Column end is the one thing that is constant. This is the benefit that I'm getting with what with that with writing all of these coordinates, right? Because I have seen that yes, my column end is same, so I don't need to do anything. What is changing? My row, the value of my row coordinates, right? So I just iterate from row start to row end, and my num plus equals to 1. And after that, once I'm done with this, what I'll do is I'll just decrease the size of my column end, because I've already already traversed through that. Okay, by the way, even though we are checking this condition while row start is less than equal to row end, there we need to check this condition again. Why? Because we have changed the value of row start again. So if our value was like this, 3 is less than equal to 3, right? But after that I have increased the size of my row start. My row start is now 4. Okay, so after that I need to check again if because how I'm going to iterate, I always iterate from row start to row end. Okay, but if my row start is greater than row end, then it will give me an unwanted error. So that is why I am checking a boundary condition which is like this: row start is less than equal to row end. I am just taking it again just to be on the safe side. Okay, because I have already changed my value of row start here. If I hadn't, then I don't need to check that. Okay, so now now I'm just moving to the left side. Okay, now I'm moving to the left side. And how do I move to the left side? For that, this for that again, this row part is constant, but what about my column part? My column part is decreasing. It was 4, then 3, then 2, then 1. Okay, so if this, then what? And sorry, that my for I'm right now just printing the matrix. Okay, I'll come to that 11 the PowerPoints part. I'll come back to them again, because that is very easy. Okay, just forget about it right now. Let's mainly focus on printing this matrix. Okay. My throat is gone. For I in a range of what? For I in range of we have I am going to move back, right? So how do I move back? Column end. Okay, column end to column column start minus one, because it because I'm going to iterate backwards. Okay, so it always excludes the last value. So that is why I've done it minus one, because I need to go to till exact point of column start. Okay, so for I in range of this, what will I do is uh, my row end will be the first part, right? And what about the other part? The other part will be I, and after that it will be equal to num, and num num plus equals to 1. Okay, done. uh, Done with this part. And then I'll need to just check sorry and after that I'll need to do what? I'll need to decrease the size of my, sorry, and after that I'll need to do what? I'll need to just sorry, decrease the start of my row end by 1, right? Because we have already done for that part. Now I'll just do the same thing. I'll check if my column start is equal to less than column end, because we have again changed the value of column end here. Okay, and now I'll what I'm going to print is I am printing that upwards part, right? I'm moving to upward side. Okay, so column start is less than equal to column end. Okay. So after that, for I in a range of, since I'm moving upwards, so I'll move from row end till row start minus 1, and this minus 1 denotes that I am moving backwards. Okay, so this is how you iterate in Python. In C++, you can just you can just start from I equals to row end till the time of I is greater than equal to row start I minus minus. Okay, so gi, and this part will be column start. Why? Because right now I'm moving like this: 4 0, then 3 0, then 2 0, then 1 0. So this 0 part means column start. Column start will always be the constant part, and this part is changing. Okay, so gi column start. Okay, so gi column start will be equal to what? It will be equal to num. Okay, and num plus equal to 1. And once I'm done with this, I'll just increase the size of my column start plus equal to 1. Okay, so this is all that I need to do for a matrix. Now I'll just try to print it first. Okay, so for I in G, okay, and for J in I, I'm right now I'm just printing my 2D matrix. Okay, so print J, end it with space, and then print next line. Okay, so right now I'm just testing how my does my matrix appear like I want it to be, or is there, sorry, is there some sort of error? Okay. Okay. Now I'll try to execute it. Just give me a second. Okay. The value is, let's say, 5. 1 2 3 4 5 6 7 8 9, and then this, then this, then this. See, it works perfectly. And after that, what, let's say that my matrix is 2 1 2 3 4. Okay. What about my matrix? My matrix is 7. Great. What about when the number is even? 6. So 1 2 3 4 5 6 7 8 9 10 11, then 16, then 20, then 24, then 27. Perfect. I am done with printing. Just give me a second. Okay. Okay, so now I'm done with printing my matrix, and now I need to just now I just need to calculate that power points, and I need to, what I need to store their locations. Okay, so for that, what I'm going to do is I'll create a variable named total. Total will be equal to 1. Okay, simple. And I'll have two lists, x and y list. uh, X will be storing the x coordinate, y will be storing the y coordinate. Okay, so total, sorry, total, uh, 1, because 0 comma 0, it will always be a part, and the constraint starts from 0. Okay, sorry, the constraint does not include 0, so there will always be this one power point. Okay, so the total is always 1, and 0 comma 0, I have already included them. Now I need to just come to this part, and I need to check if the number, if the number that I'm inserting is divisible by 0. If the number is divisible by 0, right, that is what I'm going to suppose to check, right? If it is the case, then uh, append what, append append the this row start as the x column. Okay, and append the I as a y column, right? This is how I store a value, and I'll just copy this part, and I'll paste it to all these parts. I am just checking the number that I'm putting in that particular space, if it is a divisible, if it is divisible by what, if it is divisible, sorry, if it is divisible by 11, then store their x and y coordinates, right? Because that is what we are supposed to do. Simple. Just okay, okay. So I actually need to change their values. Here x will be I just need to put these values, the x and y of that respective place. Okay, so it will be column end. Done. What about this? Mm, Here it's row end, and here it is I again. Okay, here my x dot append I, I'm just changing their value with all of these values, since here the y is column start, so I'll just append that here. Okay, done. So I've printed my matrix, and now I need to print this. Okay, let me look at the print format. So I have to print like this, total PowerPoints, and after this I have to print the coordinates in this format. Okay, so keep this formatting in mind, because if you don't format it like this, I think you'll get error, and this error won't be like a presentation error. Okay, so total power points. Okay, total power points, and after that, what I'm going to do is, sorry, this is in the part. Okay, plus I'll just typecast my total is the value that is storing the total number of power points, right? Okay, okay, I haven't increased my total anywhere. So don't forget that you have to increase the total, because total is responsible for counting the total number of power points you have, right? Total plus 1, and after this total plus 1, again total plus 1. Done. So I just typecasted it into string, and I'll just print it. Okay, now comes my next part. Now I need to print all the coordinates, right? So I'll just move I'll just print all the coordinates. And how do I do that? I just count how many total number of coordinates there are for I in range of len of x, because if there is a value in x, then there is a value in y also, right? Because I've appended both at the same time, so their length will be same. Okay, so how do I print it? Print, uh, just keep how they are supposed to print. Okay, so just keep that in mind. Plus you need to typecast it, these values, they are in, so you have to typecast it into string, because I'm formatting them, sorry, and because I'm just formatting them a little bit. Okay, plus str of y, and after that I think, sorry, and after that this, within this, yes, okay. So I think I'm done with this. Now let's try to execute our code. Okay, I'll just input 5 0 4 3 0 2 2 total power points 3. I think I made a mistake. str, okay, not x, str x I and str y I. Okay, okay, done. I run my code again. See, 004232, and what was my output supposed to be? 0042 and 32. Perfect. My code is working perfectly. If it was this, okay, I'll just show you again. 004232. Okay, and if my string was, sorry, if my matrix was 2, then this was 1 2 3 4 3, and total power points were only 1, and their location was 0 comma 0, right? And you can just do this for any number, right? Even 6 also. So for 6, let's see. The first power point is at 0 comma 0, right? That's a given. What about the second power point? It would be at 11, right? And what will be its location? Since the indexing starts from 0, its location will be 5 comma 5, and we have printed that. Awesome. What about the second coordinates? What about the second multiple of 11? That will be 22, right? What is the coordinate of 22? It is 1 comma, since this is the first row, and 22 is at the second column, right? So it should be 1 and 1 comma 2. It's 1 comma 2. What about the third multiple of 11? That is 33, right? So it is at second column, second row, and third column. Okay, so sorry, second row and second column. So we have 2 comma 2. So this was our approach for Chakravyuha, and Chakravyuha was a really interesting question, and I hope you enjoyed this video, and thank you a lot for watching this. And if you have any questions, feel free to ask them in the comment section. Thank you.